Hello students, welcome once again. Now today, as you can see, we are going to take up the practice sheet or the practice questions for advanced, JEE advanced, for the topic, for the chapter quadratic equation. Now let's start. You all know, we already upload this sheet in PDF format on the, you can get it as a post. Okay, so my suggestion, my request to all of you is try to solve this question before watching this video. Okay, that will really be helpful. So chaliye, let's start. So that's the first question, the number of integral solutions of this equation. So the equation is y square times 5x square plus 1 is equal to 25 times 2x square plus 13. Okay, where of course we need integral solution. So in that case, see, I don't think there was any requirement of writing this, because when they said you need integral solution, so of course we need only those x and y which are integers, positive or negative, whatever, but they have to be integers. Okay, so now see how I tried to solve this question. I thought that, see, since x is an integer, y is an integer, so y square, integer square, so it has to be a perfect square in that case, and 25 being a perfect square, so the best and the first choice should be, if I equate y square by 25, and then of course the second factor on both the side will get equated automatically, isn't that? So now if you solve it, so no doubt about it, you have y as plus minus 5, and in this case you have 3x square is equal to 12, so that means x is equal to plus minus 2. So that's one possibility. But then some of you must be thinking that aren't there any other possibilities? So of course there can be, but then I try to figure out. Okay, so then what I thought, since it's a perfect square, y square is a perfect square, so it's not possible that I combine some part of y here and then treat it here. I mean, it's a perfect square, 25 is a perfect square, so this match was very clearly visible and very obvious. Okay, now the second thought was, what if I equate 5x square plus 1 with 25, or any product of 25. It's not necessary to be 25, it can be any multiple of 25, but the point here is that, see, it's an odd number. It's an odd number. 2x square plus 13 is an odd number. Okay, you multiply it by 25, any odd number by 25. At the unit place, you will get a digit as 5. At the unit place, we will get digit as 5. Okay, but if you come here, what will you get? So if x square is even, then you will get at the unit place the digit as 1, and if x square is odd, the unit place digit will be 6. So is it possible that this get equal to, I mean, in case like 25 and y square get equal to this? My feeling is it's not possible. Okay, 5x square plus 1 can never be equal to 25. That's not possible. If you think, then you can equate it, or a multiple of 25, again it's not possible. Okay, that's what I tried to explain you, because here if it's a multiple of 25, it's an odd number. Okay, so then in that case it has to be something like unit place digit should be 5, whereas here the unit place digit is either 6 or 1, so not possible. So according to me, the answer should be 4. So there are 4 such combination: plus 5 plus 2 plus 5 minus 2 minus 5 plus 2 minus 5 minus 2. Okay, so that's an easy question though, but a different question. It has nothing to do with solving the equation and thinking about how to solve the equation. It's all about thinking the possibilities. Since you have product of two factors in LHS, product of two factors in RHS, and all the numbers are integer, hence what I try to do, I just equated the possibilities of equating the factors. Okay, so that's what we can think in this. Now moving to second question, I really like this question. The question is complete set of real values of a for which the equation has all its roots real. So how many roots are we expecting? It's a 4-degree polynomial, so of course it will have 4 real roots. It will have 4 real roots. Okay, now for a 4-degree polynomial, and since its leading coefficient is positive, okay, so it will start from infinity, and for 4 roots it need to have exactly 3 terms. Okay, and then only you can expect to have exactly 4 and all roots, of course 4 real roots. Okay, so for that the necessary condition is not sufficient. Why so? Because even if we have let's say 3 turn, it's possible that you don't get even a single real root, or it's possible that you get only 2 real roots. So there are so many other possibilities, but without having 3 turns, okay, you can't have 4 real roots for sure. So it's a necessary condition. So let's first apply this necessary condition. So what it says, so for a polynomial curve to have turn, the turning point are the stationary points in that case. So what are stationary points? The stationary points are those points where the derivative must be 0. So I didn't say where derivative is 0, okay, because derivative can be 0, still a point might not be the stationary point. The example is the curve of x cube, okay. So for y is equal to x cube, its derivative is 0 at 0, but it's not a turning point. I mean turning point means, what I mean here is U-turn, okay, taking a complete turn there, okay. So anyways, so for 3 turns, that means the first order derivative equal to 0 should have 3 real roots. So now let's do it. So what do we get here? So it's 4x cube. So it's 4x cube minus 4ax plus 1 equal to 0. So this equation should have 3 real roots. But then again, there's a problem. I mean, it's a cubic equation. It's not that easy to comprehend the types of roots, what will be the roots, what will be the interval in which they lie, so easily for a cubic polynomial. So again, what will I do? I will go with the same logic that for cubic equation to have 3 real roots, its derivative equal to 0 should have 2 real roots. Why? Because again, a cubic curve, okay, whose leading coefficient is positive, for 3 real roots it need to have 2 turning points. So those are the points where its derivative is 0. So f double dash x must be 0. So what does that give us? 12x square minus 4a equal to 0. So from here we get x, bacho, which is root of a by 3 and minus times root of a by 3. Okay, so these are the 2 turning points. Okay, now as I said, having turning point is a necessary condition to have real roots. Okay, number depends on the number of turning point. So for 3 real roots for a cubic polynomial, you need to have, it's a necessary condition to have 2 turning points, but it's not sufficient. So what shall we do to make it sufficient? So that you can see here with the help of curve. See, what can we say here is, on the left root, for the left root, on the left side turning point, the point where f double dash x is 0, the value of the cubic polynomial curve should be positive. So what does that mean? That simply means f dash of minus times the square root of a by 3 should be greater than 0. So what is it? So it is minus 4 a raised to the power 3 by 2 by 3 raised to the power 3 by 2 plus 4 times a raised power 3 by 2 by root 3 plus 1 should be greater than 0. That's one condition. But see, if you observe it carefully, so from these 2 terms we can take 4 times a raised power 3 by 2 by root 3 common. So it's 1 minus 1 by 3 plus 1, and that's always positive. Why so? Because a has to be positive. Why? Because the turning point, the roots of quadratic is square root of a by 3, so a has to be positive. Otherwise, this second degree like f double dash x is equal to 0 won't have any real root. If it doesn't have real root, it can't have 3 real roots. If it doesn't have 3 real roots, then the preceding equation fx is equal to 0 can't have 4 real roots. So in that case, root of a must be defined. I mean, it should be real. For that to be real, a has to be positive. Okay, so for any a positive, this is always positive. So this is done. So that means at the first turning point it's positive, but it may happen it's positive here and then it goes like this. So what next? In that case, for this point, this value should be negative. So the next thing is that f dash of square root of a by 3 must be negative. So what will we get at? So that will give us this by 3 raised power 3 by 2 minus 4 times a raised power 3 by 2 by root 3. What is plus 1 is less than 0. So if we take it that side, so 1 is greater than 4 a raised power 3 by 2 by root 3. 1 minus 1 by 3 is 2 by 3. Okay, so this gives us, bachcho, what does that give us? So this gives us, so where shall I write? I think that might not be visible. Do we have, yeah, we have one more slide. So this gives us a raised to the power 3 by 2. A raised to the power 3 by 2 is greater than 3 raised to the power 3 by 2 by 2 cube, 8. So a raised to the power half, so taking cube root both the side, so it's 3 raised to the power half by 2, so that means a is squaring both the sides and both the sides are positive. So a is greater than 3 by 4, that's it. Now what if a is equal to 3 by 4, even if a is equal to 3 by 4, in that case also, it will just touch the x-axis. See, there we will count these two roots as identical and repeating roots. Okay, in that case also it will have 3 real roots. Am I clear? Okay, so that means even if we include it, then also it will be fine, then also it will be okay. Okay, so that's the necessary condition for the f dash x equal to 0 equation to have 3 real roots, and hence now the 4-degree equation, which was the question here, this may have 4 real roots, but now you will say may have. How can we ensure it will have? Okay, so anyways, looking at the option, this should be the correct one because that's the only option, but then we need to justify why for any such a greater than 3 by 4 it will have 4 real roots, because as I said just few moments back that it may have 4 real roots. See, now what I did in that case to verify it, I just rewrote this equation. Okay, this equation. So x raised power 4 minus 2ax square plus a square plus I think a minus x equal to 0. Let me quickly go back and check. X minus a, sorry. Yeah. So it's x minus a equal to 0. Now look at this. Isn't that a perfect square? Of course it's a perfect square. Is equal to a minus x. Is equal to a minus x. Okay. Now x, for every x which is less than a, for every x less than a, okay, so this equation, this will be positive. So that means x square minus a is equal to root of a minus x. So if we consider any a rather just a minute, a minus is a minus x. So for every x less than a, okay, so a is root 3 by 2. Okay, so if I consider where's the curve? Here's the curve. So just a minute, the turning points, let's say, let me try to draw one more curve here, bacho. I thought something about it. Let me just think about it once again. Right. So if x is less than root a by 3, okay, so let's say x is less than root a by 3. Now this is positive. Okay, now you can write x square as a plus under root of a minus whatever, any x which is less than root a by 3. Okay, now of course this is again less than a, because square root of a minus something. Okay, so which is less than a, bacho. Now if it is less than a, so that means again you have two possibilities. So x square is equal to a plus this, and x square is equal to a minus this. Okay, and then both are positive. Both are positive. So here you remove square root plus minus sign, here you remove square root plus minus sign, and hence you will get 4 real roots. Okay, hence we will get 4 real roots बच्चों. So that was my way of explaining it. Okay, so once we said that x is greater than, so once we ensure that there are 3 turning points and using that value for a is greater than root 3 by 2, we can just justify from here something from here to say that it has 4 real roots बच्चों. Okay, so that's it. Now moving to the next question. Consider 2 quadratic expressions, this and ax square plus px plus q, such that their discriminants are equal. If fx is equal to gx has a root, x is equal to alpha, then what can we say about it? Now look at this question, and if you people are solving the previous year question, you will find several many question in this form. See, I'm not saying exactly similar question, not at all. My point is involving so many things, like considering 2 quadratic, then their discriminants are equal, then saying that fx is equal to gx is in equation which has a root alpha, so involving so many different type of things from the same chapter. Okay, so that's why I decided to pick up this question for you people as practice here, because see, I want to tell you that sometimes even if the statement is quite lengthy, there are so many information, if you solve it patiently, coolly, then you will find that when you solve it, it's really a simple direct question. Okay, that's what I found here. So we are given discriminant, so b square minus 4ac is equal to p square minus 4aq. Okay, then I did something, I believe I brought it this side, took 4ac that side, so if I take 4a common, it's c minus q, yeah, and then b minus p into b plus p. Okay, now fx is equal to gx has a root, common root, I mean it has a root which is x is equal to alpha, so fx is equal to gx means x square into a minus p, rather, okay, wait, x square term will get cancelled, isn't that? ax square is common. Okay, so that means bx plus c is equal to px plus q, and x is equal to alpha is its root, so if it satisfies, so it's like b minus p alpha is equal to q minus c, so alpha is q minus c upon b minus p, isn't that? So if I put that value here where we had b minus p into b plus p is equal to 4ac minus q, 4ac minus q. Okay, so if I bring it this side or take this that side, so b plus p upon 4a is equal to actually minus alpha. Fair enough? Okay, so that's what we got. Now alpha will be the arithmetic mean of fx is equal to 0 and gx is equal to 0. Alpha be the arithmetic mean of roots of fx 0, alpha be the arithmetic mean of roots of gx 0. So the roots of those, let's say its roots are alpha 1, alpha 2. So alpha 1 plus alpha 2 by 2, which is minus b by a. And then its roots are beta 1 and beta 2. So beta 1 plus beta 2 it is minus p by a, so there is no 2 here. So sum of root there, sum of, so since we need to see whether alpha is the am of their roots or not, so if you write their arithmetic mean, so the arithmetic mean will be, so it's like minus b by a plus p by a 1 by 4 times. Okay, now minus b by a, so if I take it inside, this is alpha 1 plus alpha 2, minus p by a is beta 1 plus beta 2, so this is nothing but 1 by 4 alpha 1, so sum of all the roots divided by 4, that's what, and that's how we define the arithmetic mean. Hence the first option is the correct option. Alpha is the arithmetic mean of the roots of fx is equal to 0 and gx is equal to 0. A simple question, of course, I accept it. Okay, but then the different format was there, so that's why I decided to pick it up. Now moving to the next question. If alpha, beta, beta, gamma, alpha, gamma are the roots of this quadratic, okay, you may like this question, bachcho. I'm pretty sure. So let us first write what have they given. Alpha, beta are the roots of a1x square plus b1x plus c1 equal to 0. It is ci. Okay, no doubt about it. Now beta, gamma are the roots of a2x square plus b2x plus c2 equal to 0, and then gamma delta or gamma alpha are the roots of a3x square plus b3x plus c3 equal to 0. Okay. Now see how, what is it? Sum of summation over alpha. So that is sum of all the roots alpha plus beta plus gamma. Now what is this one? So taken two at a time, so alpha beta plus beta gamma plus alpha gamma. Isn't that bachon? And that's the last one is of course product of all the three rows, no doubt. Now the right side is pi. Pi I goes from 1 to 3 means it's a product. So what we have in RHS, we have in RHS as, see, if I divide by AI, so it's 1 minus BI by A1, or minus, it's minus plus C1 by A1 into product. So for I is equal to 2, so B2 by A2 plus C2 by A2 into B3 by A3 plus C3 by A3. Okay, plus k, we have something called plus k here, and this k we have to find out. Okay, now if we go with the relation between the roots and the coefficient of polynomial equation, so what is it? So it's minus b1 by a1 is nothing but plus alpha plus beta, and this is alpha into beta. Now the key lies here. Similarly, you will write it as plus beta plus gamma plus beta gamma. Similarly, 1 plus alpha plus gamma into plus alpha gamma and plus k. Okay, as I said, the key is here. Okay, now if you observe it, this is nothing but 1 plus alpha into 1 plus beta. I strongly believe all of you will agree with me and definitely will say, okay, that's the trick or that's the key here. Why? Because now once you have it, see, we had a square root, I just missed it, isn't that? And see, once I got the perfect square here, then only I realized there should be a square root, and there is a square root in the expression after pi over it. Okay, so that's it. So you have this square root, so this implies, so this is well within square root. So this is nothing but 1 plus alpha into 1 plus beta into 1 plus gamma plus k, and in LHS it's alpha plus beta plus gamma plus alpha beta plus beta gamma plus alpha gamma plus alpha beta gamma. Now you open it. So it's a clear cut thing. So it's 1 plus this entire LHS. Okay, and this gets cancelled. So k should be how much? How much should it be? It should be minus 1. So is that an option? So then k is, okay, it's an integer or numerical value type of question. Answer is minus 1. Okay, so that's it. So that was question number 4. Now moving to 5th question. The equation this has all its roots positive and real, where we are given the value of leading coefficient, which is 1, and the second highest degree term coefficient, which is minus 4, and the constant term, which is 1 up by 2 raised power 8. So has all its roots 8. It's an 8 degree polynomial equation. All its roots are real and positive, so it will definitely have exactly 8 roots. So sum of the root is minus a7 by a8, so which is 4 here. Okay, and similarly the product, see, that's the two information which we directly have from the given information in the question. So product of all the roots, so alpha I, where I goes from 1 to 8, is nothing but 8 positive. Okay, so it will be positive. So again, the constant term by a8, which is 1, so that's it. Okay, see, what we actually what I tried, because no other information was given, so actually what I tried was applying AMGM, and that hint came from this thing also, because sum of 8 numbers which are all positive is 4, and sum of a product of all 8 numbers which are again all positive is 1 by 2 raised power 8. So if I go for AMGM inequality greater than equal to their product raised to the power 1 by 8. Now if I put the values, so the value is so this is 4 by 8, which is half, isn't that? Is greater than equal to, again this is this, and power 1 by 8, so this is again half. So actually what happened is AM is equal to GM. And when will that happen? This will happen when all are equal. alpha is equal to alpha j. Now that's it. So all the roots are half. Okay, and then only the product of all of them is 1 by 2 raised to power 8. So all the roots are equal, alpha 1, and now that's done. Now I think everyone, because see, now it's a simple thing. It's alpha minus half raised to the x minus half raised to power 8 is a polynomial, or otherwise by using, because you are asked to find these coefficients, so by using the values like the relations, sum of the roots taken 2 at a time, taken 3 at a time, taken 7 at a time, you can find all these values. Okay, so now any one of us can complete it so easily. Now moving to the next question, which is this, the number of real roots of this equation. So fx is again a cubic polynomial, so that's our fx. Okay, now see, again it's a cubic polynomial and number of real roots we have to find. See, if you go for its f of x, so of course it will be cube over cube, 9-degree polynomial, so there's a potential of having all 9 roots to be real. So the maximum answer can be 9, minimum can be anything that we have to analyze. Okay, so whenever it comes to the analysis of any such polynomial equation which I can't factorize, I can't use any other method to algebraic method to solve it, what I do is I will go for its derivative. Okay, now see, the beauty of this question lie here. The value at which the curve, the cubic curve 2x cube minus 6x plus 1 takes turn are minus 1 and plus 1. Okay, so if I go for f of minus 1, so the value is 7 and then minus 2, it's 5. And if I go for 1, then it's minus 3. So the curve will be, and f of 0 is positive. That's how the curve of this y is equal to 2x cube minus 6x plus 1 may look like. Okay, now see, then I tried to think. Let me tell you all what I tried. So since f dash t is 6 times t square minus 1, isn't that? Okay, so that means f dash of t, so it's t can be anything, so t can be fx. So it's 6 times, okay, and then fx whole square, okay, minus 1 equal to 0. Why so? Because again, if I have to analyze, so since this is again a 9-degree polynomial equation, so as I said, if I can't apply algebra, this is the first thing which I try to take its derivative. So how many, see, that will give us an idea. Actually that gave me the idea how many real roots it can have. Number of turning points is the same concept again and again I am using here. Okay, so now fx whole square, so fx is either 1 or fx is equal to minus 1. Now fx is equal to 1 means 2x cube minus 6x equal to 0. So you have 3 roots, isn't that? So x is equal to 0 and then maybe x is equal to what? Root 3 minus root 3. Okay, now fx is equal to minus 1 means 2x cube minus 6x plus 2 equal to 0. So it's x cube minus 3x plus 1 equal to 0. Okay, what do you think? Okay, so at 1 it's negative, minus 1, very good. At minus 1 it's positive. Okay, so this also has 3 roots. Why? Because see, the same trick I applied here. Minus and 1 are the turning points for this curve. At minus 1, since leading coefficient for this cubic polynomial is positive, it starts from minus infinity, minus 1 is positive, plus 1 is negative. So of course it will intersect the line at 3 points. So 3. So how many roots we have? 3 here, 3 here, and then its derivative will be f dash x into. So f dash x equal to 0 has also 2 roots. So total number of roots it has are 8 real roots. So that means the curve, 9-degree polynomial curve, has 8 turning points. So there's definitely a chance of having 9 real roots. But then again, the point is of chance of having. Now there was the problem. Okay. Now for that I went. Now see that I might have, because this I analyzed later. Because from here, the one thing I could only get was it may have 9 real roots, okay, because you have 8 turning points. But then to ensure whether it has exactly 9 real roots or exactly 6 or 5 or 7, whatever, how will we do it? Okay, so for that I then went back to the curve and see, tried to analyze that this peak is at 5 and this peak trough is at -3. Okay, now so it has 3 roots, 1, 2 and 3. So one root is between, and one more thing, see, for this curve if I draw a line, horizontal line between 5 and -3, it will intersect the curve at 3 points. Now what does that mean? That means any equation fx is equal to p, where p lie between -3 to 5 has 3 real roots. Okay, now here one thing is sure, that one root is between, as we can see, between 0 and 1. One root of fx is equal to 0 is between 0 and 1. Another root is beyond 1, but let's check, is it beyond after 1? It's 2. So let us check the value of this polynomial at 2. So at 2 it's -12 and 16, it's positive. So it's at 2, it's, let's say it's positive. So I mean it's positive. So if it's positive at 2, that means second root is between 1 and 2. Likewise from -1 here, now that's the third root on the left side of -1. So again I will check it for -2. So -2, it's negative. Yeah, it's negative. Okay, so that means third root is between -2 and -1. Okay, now when we come here for the equation which is f of x. Okay, so now our equation is f of x equal to 0. Fx equal to 0 has roots in the interval -2 to -1, 1, another one is between 0 to 1, another one is between 1 to 2. Okay, let's say the roots are beta 1, so one root is here, I call it beta 1, one is here beta 2, and the root is here beta 3 of t equal to 0. I mean I'm replacing fx by t. Okay, now if I say for beta 1, that's true, yes or no? Right, if I replace t by beta 1, it's a root, it will satisfy. But then what will happen when I'm saying that f of x is equal to beta 1? Now doesn't this has 3 roots? Why? The logic lie here. As I said, fx is equal to p has 3 roots. Why? Because any horizontal line, now beta 1 is a value, it's a root of some equation, it's a value between -2 to 1. So if beta 1 is anything between -2 to 1, so that means I draw a line between -2 to 1, it will intersect the curve, polynomial curve at 3 points. So fx is equal to beta 1 has 3 roots, okay, and then it will satisfy this equation. Every root will satisfy this equation here, isn't that bacho? Every root will satisfy the equation here. Similarly, fx is equal to beta 2 has 3 roots. Fx is equal to beta 3 has 3 roots. All those roots will satisfy this equation, and hence the equation f of fx has 9 real roots. So I found this question to be a good question as far as the analysis was concerned. I mean as far as the way I at least analyze it or solve it. Of course, as I always say, if any one of you has better method, shorter method, then do discuss it with me, do let me know. Okay, so now moving to the 7th question. Now this is again a different type of question, has k real roots, then k is equal to c. I didn't even try to think algebra here, I just directly went for the curve or the calculus. Okay, so what I saw here was x is equal to 1, and then another one is x is equal to 2. Okay, and y is equal to x cube curve, we all know. Something like this. That's the curve of y is equal to x cube. Now, let's start. See, I just, how I thought. So, as x approaches 0 from the left side, negative side, of course, 1 by x approaches minus infinity, and as x goes to infinity, I am drawing the curve of the left hand side. As x goes to infinity, all the three terms will approach 0. So, it will approach 0 from the left side, I mean from the left side, negative side. So, that's it. So, you got one point of intersection for the LHS curve between LHS and RHS curve here. Now, moving on the right side of 0 again, when you start from the right side of 0, it starts with infinity. Okay, and as you approaches 1 from the left side, it approaches, this term approaches infinity, but from on the negative side. So you have second point of intersection here. Similarly, when you approach 2, okay, so and again on the right side of 1, this gets infinity, and as you approach 2, it goes to minus infinity, one more cut. And then on the right side of 2, it starts with infinity, and as you go to infinity, it goes to 0. So I am not claiming that there won't be any other turn. I am not claiming like that. Neither am I claiming that there's no turn. I mean, there's no turn here. I'm not claiming that there's no maximum minima here. No, nothing of that sort. That we can check only with the help of derivative. But one thing is very, very clear. Okay, there is a point of intersection, there is a point of intersection, there is a point of intersection, there is a point of intersection. Now, if you feel that there might be 2 points of intersection, see, that won't happen actually. That won't happen for sure. For that, you need to go and take the help of derivative, and that will be a longer. But still, since there are so many things which we can do on the basis of instinct, it's really very clear to me that it will intersect it in 4 ways like this. Okay, rest, if you want to ensure that there's no curve on of this type somewhere here. I mean, let me draw it with some other color. Which color shall I choose here? White maybe. Yeah. So if you think that there can't be any curve, something like this, if you have something in your mind, then for that you need to take the help of derivative. I didn't do it because I was very clear that these many will be the number of points of intersection, and that was the answer, 4. Okay, so the question I got as doubt here, the answer I confirmed from the student. He said, oh, it's 4. So that's it. Now this is one question, right, where x 2022 number of possible choices of x1 is n, then log n to the base 2 greatest integer, the value of it is. Okay, see, what I actually did was, see, one thing, like if I put this value here, okay, so x3 is 4 times 4 square, x1 1 minus x1 and 1 minus x2, which is, so what happens is, brother, 1 minus 2x1. Okay, so that is one thing, that when you equate x3 with 0, you have a root here, you have a root here, you have a root here. Okay. Now, actually I thought so many things about it, but then I zeroed down to this thing. I multiplied both the sides like this. So the x 2022 equal to 0. So for x2, okay, 4x1 1 minus x2, 1 minus x2. For x4 it will be 4x3, 1 minus x3, and so on and so on. For x 2022 it will be 4x 2021 into 1 minus x 2000. That these individual terms got cancelled, except x1, of course, except this one. So now what you have is x 2022 is equal to 4, how many times? So 4 is 2021 times, x1, 1 minus x1, 2. See, we already know it's 1 minus 2x1 whole square, and then it's 1 minus x3, 1 minus x4, till 1 minus x 2021. Okay. Now I can write it as 1 minus x2 whole square. Now x2 is 1 minus 2 times 1 minus 2x1 whole square. Degree, how many roots? 4 roots. Okay, so start. So 1 root is 0, 1 root is 1, 1 root is 1. Okay, now if we count from here, okay, so this is, so here we have 2 roots, so 2 roots, then the degree is 4 roots, next it will be square, degree is 8 roots. So till 2000, so for x3 we got 2 cubes, so it will be 2 raised to the power 2021. Now number of roots will be 1 plus for 0, 1 for x1 is equal to 1, then 2, though they are identical roots, but 2 square, 2 cube, 2021. Okay, so but wait, number of possible 2 roots, no? Because if it's a perfect square, choice is only 1, no? So 1, 1, so this is 1, I mean this is 1 root, this is 1 root, 1 root. Okay. Wait. Be counted because in any case this is equal to 0. So every perfect square is equal to 0 will lose their importance. Okay, so all those power 2 will be lost. So it will be 1 here for this also. It will be 2, then it will be 2 square. So it will be, I think, 2020. It should be 2020 in that case. Okay, because all perfect square will lose their importance. So it will be how many roots? Again, let me just count. Okay. Patience. Okay, wait. This was for x2, 1 roots, x3, 2 roots, x3, 2 roots, x4, 2 square roots. Okay, so it will be 2019, 2 less, 2019. Okay, so it will be 2019. See, that counting has to be done very properly. So I might be getting confused, but okay, we need to do it very patiently. Okay. So it's 2 plus, now that's a GP of 2020 terms, these many roots. Okay. Plus 1, right. So log of n to the base 2. Log of 2020. That's all. Actually, I remember the answer. To be very true, I remember the answer. Okay, so that's why when I got it as, because when I solved it, again there also I have to count it 2-3 times. I mean, to be sure. So I remember that answer is 2020. Okay, and then see, that's very logical. I think you all can understand this because the integral part will be 2020 only. Okay, so that's it. So now moving to the I think the last question of this, p of x is this, q of is that, if the unique pair of real numbers, so that px into qy is 20. Okay, so what is px? 5 by 3 minus 6x minus 9x square into py minus 4y square plus 4y plus 13 by 2 is equal to 20. See now, how did I try it? See, what I thought was, since this seems to be a perfect square, this seems to be a perfect square, so I just converted to perfect square, thought nothing else. Okay, that was just an observation. Then I thought, okay, we'll see it later. So minus times, so it's 3x square plus 1 whole square, isn't that one? 3x, sorry, 3x plus 1 whole square, so 9x square plus 6x plus 1. So of course you subtracted 1, you add 1. This is one thing. Now similarly, it's 13 by 2 minus common, so it's 2y and then minus 1 whole square, isn't that? So it's 4y square minus 4y, again plus 1, so you subtracted 1, you need to add it. This is 20. So now 5 by 3 plus 1 is 8 by 3 minus 3x plus 1 whole square, and 13 by 2 is 15 by 2 minus 2y minus 1 whole square is equal to 20. Now just to check what I thought, just multiply these two. The moment you multiply 2, 4, 8 and then 3, 5, 15, 4, 5 is 20. What does that mean? That means this has to be 0, this has to be 0, and that's it. So x is equal to minus 1 by 3 and y is equal to half. That's it. Okay, so sometimes you need to think like that also. I mean, whatever you are observing, just follow it. Follow your instinct. And one more thing, see, since you have 20 and when you come across this situation, of course, these are the constant. Why not to multiply, and then because that will give us an idea what else do we need. I mean, which number, are we close to 20? Are we far away from 20? Is there anything, any number which you get by multiplying these two which is related to 20? Whatever. That's what I thought when I multiplied these two numbers, but then I got the number itself. So then the answer was very clear. So that's it. So those were few questions for your JEE Advanced 2025. In the next one, I will be bringing the questions of binomial theorem with you.